So in the sorting parabolas activity, some of the vocabulary I started to talk to you about, we're going to solidify that vocabulary today, show what it means on the function. The first one is, what do we call this function? And we said that this is called a parabola. And that is the name for the U-shaped graph. Because as you recall in our sorting parabolas activity yesterday, all of the graphs were U-shaped. Now, you didn't have a full picture of all the graphs, so some of them may have seemed like maybe they weren't U-shaped, but trust me, had the graph continued, all of the functions we looked at yesterday had a U-shape to them. So anytime you see a U-shaped graph, you should know, hey, that's a parabola, which means that's representing a quadratic function. Another term we talked about yesterday was vertex. And we said, well, the vertex was either that highest or lowest point of that parabola. It is called an absolute minimum. When at the bottom of the graph. And it is called an absolute maximum. When at the top of the graph. In this particular instance that we have right here, our vertex is at the bottom of the graph. So in this instance, we would talk about this being an absolute minimum, meaning the graph does not go below that point. That is the lowest point that that function can have based on the shape of the graph. And we will start talking about other things that cause this shape. And how do we know when the graph is going to open upward and open downward? These are all things that we are going to discuss in today's lesson. The next term we also talked about yesterday, we talked about axis of symmetry. And we said this is the line that divides the parabola into two congruent halves. Yes, that divides the parabola into two congruent halves. Now, the fourth term in here is one we didn't really talk about yesterday because it actually has 4 different words that mean the same thing. And I know this gets confusing. You already know one of the terms. You've talked about these points before, and I actually think that this term might have been used by some in the sorting parabolas. One of the 4 terms for these 2 points here are called x-intercepts. It's where the function crosses the x-axis. When we are talking about a parabola, there are 3 other terms that they use to mean the same thing. One of the terms is called the roots. If they ask you for what are the roots of the parabola, they're asking you where does the parabola cross the x-axis. If they ask you for the zeros of the parabola, they're asking you where does it cross the x-axis. And if they talk about solutions, they're talking about where does it cross the x-axis. So all 4 of those terms are used at different times when they're talking about parabolas. Now, most of that we really don't get to till Unit 3. Unit 2 is focused on the features of the quadratic function and how it behaves the way it behaves, whereas Unit 3 focuses on the math. How do we solve the function? What math goes along with the function? So this unit we're going to focus on more how it behaves, and Unit 3 we will get into the math of how to solve and how to use that. So we won't talk about x-intercepts, roots, zeros, or solutions that much this unit. That is really more of a Unit 3 topic, but I wanted you to be aware. Going back one thing, because I realized I missed when I was talking about axis of symmetry. Again, just to show that this distance from the axis of symmetry to the point, they are the same distance apart. That's what that symmetry means. All right, now when we talk about the equation of a parabola or of a quadratic function, there is actually 2 different forms. There's what's called a standard form, which I'm going to mention briefly here. We'll look at briefly, but really standard form is what Unit 3 focuses on. For what we're going to do here in Unit 2, we're going to focus more on the vertex form, but you need to be aware there are 2 different forms of the quadratic function. The standard form, you have f of x equals ax squared plus bx plus c. And you can see that a is whatever value is in front of the x squared term. The b is whatever value is in front of the x term. And the c is your constant, whatever is at the end. And again, we will come back to standard form and do a lot more with it, but it is more Unit 3. We're really going to focus the rest of this unit on the vertex form. And that actually is a good thing, because vertex is the easier of the 2 forms. The vertex form of the quadratic function gives us all the information we need to talk about the function. And the main part, it's called the vertex form because we can get the vertex directly from the equation. So the vertex form is f of x equals a times x minus h quantity squared plus k. The h is the x value of your vertex. And the k is the y value of your vertex. So if you have vertex form, you know your vertex just by looking at the h and the k. Now, the reason they have to use h and k, yes, it's an ordered pair. Ordered pairs are always represented by x comma y, but x and y are already assigned values in the equation, so they have to use 2 other letters to represent that vertex. H comma k would still be graphed as h representing your x value, k representing your y value. The one thing to keep in mind, the equation is x minus h, which means if there's a negative in the equation, h is positive. If there's a plus in the equation, h is negative. So h will have the opposite sign of what it shows in the equation. And we will look at this more. K is whatever sign. If it's plus K, it's a positive number. If it's minus K, it's a minus number. H is the only one that goes opposite because of the way the equation is written. Again, we will look at that more in depth as we get into this unit. All right, the idea of the parent function. The parent function is the most basic graph of that function. Now, there is a parent function for a linear graph. You've graphed it before. We just don't usually, when we're teaching linear functions, we don't usually bring up the idea of the parent function yet. It is something that we wait until we get more to the quadratic and we start to understand. So I bring in linear here just to show you what this parent function means. And the parent function for the linear function is f of x equals x. There's no transformations that have happened to it. There's no plus or minus number. Your slope is 1. So if we were to draw an xy table here and use the values -2, -1, 0, 1, 2. Well, this is that function that whatever I put in, I'm going to get the same thing out. If I put in a -2, I'm going to get out a -2. Put in a -1, I'm going to get out a -1. Put in 0, I'm going to get out 0. Put in 1, get out 1. Put in 2, get out 2. So again, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. This is that line that goes directly through the origin of your graph. Again, we didn't call it a parent function, but that's really what it is. Every other line is some transformation of that line. Whether the slope changes, the position changes up or down, left or right, every other line is a transformation of that line. The same thing applies to the quadratic. We have a very basic quadratic function. It is f of x equals x squared. That is the equation for the parent function. If I take those same values and create that xy chart, -2, -1, 0, 1, 2 for my x values. Now, I have to substitute those into the function x squared to find their value. So f of -2 equals the quantity -2 squared. I'm putting that -2 in place of x. I have to make sure that if I put that in a calculator, it has to be in parentheses. There is a difference between -x squared and the quantity -x squared. If you don't put it in parentheses, the square is only touching the x. It's only going to square that value and then take it times -1. In parentheses, it's going to square whatever is inside the parentheses. So what is -2 times -2? +4. So the function of -2 equals 4. If I do the same thing for -1, the function of -1 equals the quantity -1 squared. So what is -1 times -1? positive 1. 0 squared is 0, so it doesn't change signs. We don't have to worry about that. 0 is neither positive or negative. And then f of 1 equals 1 squared. So f of 1 equals positive 1. And f of 2 equals 2 squared. So f of 2 equals 4. That squaring is how we get that U shape, because if we square a negative number, we get a positive value. We square a positive number, we get a positive value. So that is how our shape can go up on both sides, is because we're squaring that term. So if we graph this, negative 2, positive 4, negative 1, positive 1, 0, 0, 1, 1, 2, 4. There is the sketch of your parent function. So just like the linear function, every other parabola is a transformation of that parabola. So every other parabola, even the ones, all the ones you saw on the sorting parabolas cards yesterday, were some type of transformation of that parent graph. That is the most basic starting graph. Everything else is a transformation, and we do get into how we know what the transformation is, and we will talk about that in this unit. But every other parabola is based off of that first parabola. All right, the next page, we're again, this first lesson is all about vocabulary. So we're hitting the vocabulary very hard to make sure we understand the parts and what they mean. So we've already talked about some of these terms. We're going to go a little bit more in depth. Axis of symmetry. You will see, because I don't like to write out axis of symmetry all the time, when I speak I will say the full thing. But you'll also see me use capital AOS in place of that. It's just a little shortcut. Saves me a few hand cramps of having to write that out every time I have to talk about it. So again, what is it? It is the vertical line that divides the parabola into two congruent halves. The vertical line that divides the parabola into two congruent halves. And we talked about this yesterday. It always passes through the vertex. If you know where the vertex of your parabola is, you know where your axis of symmetry is. They share the same x value. That vertical line always goes through your vertex. If you know your axis of symmetry, you at least know the line of where your vertex is going to be, and vice versa. If you know where your vertex is, you know exactly where your axis of symmetry is. Now, how can it be identified in vertex form? The x-coordinate of the vertex is also the coordinate for the axis of symmetry. The x-coordinate of the vertex is also the coordinate for the axis of symmetry. This is why we like vertex form so much better, because it gives us all the information in one snapshot. I don't have to go doing solving. You're going to find in Unit 3 when we get there and work with standard form requires me to do a lot more work. Vertex form, they're handing me the information on a platter about my parabola. So for example, if they give me the equation f of x equals the quantity x minus 4 squared plus 2, all right, so again, f of x equals the quantity x minus 4 squared plus 2. We're looking at whatever number is there in that h position. In this case, it's a 4. So our axis of symmetry here would be x equals 4. It is a vertical line, so it always needs to be in the x equals format because it is talking about a line. And how that would look on our graph, we would go to positive 4 on our x-axis and draw a vertical line. So this is the axis of symmetry. X equals 4. And again, just as a reminder, I draw it as a dashed line because it is not actually a part of the function. It is what we call an auxiliary line that just helps us to understand the symmetry of the function. It is not an actual part of the graph, but it is something that we use to help us identify the shape of the graph. All right, vertex. Again, the vertex is the highest or lowest part of the graph, and that when it's the highest, we call that an absolute maximum. And when it's the lowest, we call that an absolute minimum. And how can it be identified in vertex form? Again, the vertex form is f of x equals the quantity equals a times the quantity x minus h quantity squared plus k. And again, our vertex is represented by the ordered pair h, comma, k. So if we go back to that same example from the previous problem, if we go back to f of x equals the quantity x minus 4 squared plus 2. The vertex would be the ordered pair for comma 2. It's a minus 4, which tells us that h is positive. And we always go with the sign that k has. So again, we've talked about several of these terms are ones that came up yesterday when we were sorting parabolas. I talked about that when we got deeper into this unit, we talk about how did we know which way it was going to open. How did we know when it opens up? How did we know when it opens down? So we've talked about H and K, their part. Now we've got to talk about what is A's job here. And A actually has several jobs we will learn as we go through this unit. But A's main job, that A out in front of the parentheses, that tells us which direction it opens. If A is a positive value, we know our function opens upward. If A is a negative value, we know our function opens downward. So that is the main job of A. There are some others. Again, not going to talk about all of A's jobs today, but its main job is telling me which direction it opens. So again, when the parabola opens up, the A value is positive and the vertex is known as an absolute minimum. When the parabola opens down, the A value is negative and the vertex is known as an absolute maximum. And again, it's that A value out in front that is giving me this information. So if I'm back to that parent function, f of x equals x squared. Well, really, that's the same thing as writing f of x equals 1x squared. Which means that our A value is equal to 1, which means it is positive. So I know this parabola opens upward. And again, we already did a sketch of this parent function, 0, 0, negative 1, 1, 1, 1, negative 2, 4, 2, 4. But it is that A value that tells me which direction this parabola is going to open. Yeah, negative 2, 4 and positive 2, 4. And then the next one, f of x equals negative x squared. This is the same thing as saying f of x equals negative 1x squared. So in this case, A equals negative 1. So A is negative, which means this is going to open downward. So really, we could take all those points we had on the first one and reflect it across the x-axis to open down. So we're still going to be at 0, 0. Now we're going to be at negative 1, negative 1, 1, negative 1, negative 2, negative 4, and 2, negative 4. So all we've done is change the A value to negative, which just reflects that downward across the x-axis. So now we know a lot of different information about that vertex form. We can get the vertex, the axis of symmetry, and know which direction. We will get deeper into graphing and getting specific points. On this next page, they're going to ask us to sketch a rough draft because we haven't gotten into how to get all the exact points of the parabola. But it's just a little practice of using this information we've learned today, putting it all together. So use the formulas to determine the vertex and axis of symmetry for each quadratic function. Then draw a rough sketch of the parabola on the graph provided. So again, remembering that my axis of symmetry, I'm looking for x equals h. My vertex, I'm looking for the ordered pair h, comma k. And in the margin, I'm going to write that vertex form, just the generic vertex form. So we remember it's f of x equals a times the quantity x minus h squared plus k. So if I'm given the function f of x equals the quantity x minus 3 squared plus 2, so I need to identify my h, my k, and my a value. What is the value of h in this function? 3. It's minus 3, so I know h is positive. That means I already know my axis of symmetry is x equals 3, because whatever h is, that is my axis of symmetry. What is the value of k? 2. So my vertex then is going to be the ordered pair 3, 2. And what is my value of a in this? If there's nothing in front of the parentheses, what is always there?
1.
Yeah, so in this case, my a value would be 1. So is this parabola going to open upward or open downward? Upward. A is a positive value, so we know that this opens upward. So I can start off with my axis of symmetry, x equals 3. Graph my vertex at 3, 2. And then I know it opens upward, so I'm just going to do a rough sketch. You notice I'm not worrying about any points right now, because it specifically said, hey, just give me a rough sketch. So the next one, f of x equals negative 2 times the quantity x plus 3 squared plus 3. So again, we know our axis of symmetry is x equals h. We know our vertex is the ordered pair h, comma k. So I need to determine what is my value of h, what is my value of k, and what is my value of a. So what would be my value of h based on this equation? It's going to be negative 3 because it's plus 3. If it says x minus 3, then h is positive 3. When it says x plus 3, that means we put a negative in and it ended up with that double negative. So in this case, h is going to be negative 3. So our axis of symmetry is going to be x equals negative 3. What is the value of k? So my vertex is the ordered pair negative 3, 3. And what is my value of a? Negative 2. So which direction does this open? This is going to open downward. So now I can use all that information to do a rough sketch My axis of symmetry is x equals -3. My vertex is at -3, +3, and I know this opens downward. I will tell you that a value is also going to tell us how wide or narrow this is going to be, but we'll get into that a little later. Now, this last one, determine the axis of symmetry for the following quadratic function. F of x equals x squared minus 5. This is the same thing as saying f of x equals the quantity x minus 0 squared minus 5. So what is the value of h in this equation? 0. What is the value of k? So in this case, my axis of symmetry would be x equals 0, and my vertex would be the ordered pair 0, -5. So if there's not a parentheses there, they're telling you the h value is 0. That I wanted to make sure we understood that.